Hello student, welcome to video lecture series in Engineering Mathematics 1. So after Jacobian, we have discussed how to find partial differentiation by using Jacobian, as well as with the help of implicit function how to calculate Jacobian. And the next topic is which is our today's topic is functional dependence. So what is functional dependence? So if suppose u is a function of two variables x and y, and v is also function of two variables x and y. These are any two functions of x and y. If there exists a functional relation between u and v of the type v is equal to f of u or u is equal to f of v, then we say that u and v are functional dependent. Then we say that function u and v are functionally dependent. Also, if Jacobian of uv with respect to xy is equal to 0, then u and v are functionally dependent. U and v are functionally dependent, and hence there exists a relation between u and v, and this is the definition of functional dependence. Functional dependence means if Jacobian of uv with respect to xy equal to 0, then u and v are said to be functionally dependent. If they are dependent, then there exists relation between u and v of the type v is equal to f of u. Now if Jacobian of uv with respect to xy is not equal to 0, then u and v are functionally independent. U and v are functionally independent. Hence, no relation exists between the variable between u and v. Now here, if the number of functions are less than number of variables, that is, we have suppose two functions. F1 is a function of three variable x, y, z, and f2 is a function of three variable x, y, z. Suppose this is a v and this is a u. Now for their functional dependence, so we must check for their functional dependence, we must check Jacobian of uv with respect to xy equal to 0, as well as Jacobian of uv with respect to yz equal to 0, and Jacobian of uv with respect to xz equal to 0. So you have to check all these conditions, then we see that it is a functional dependent. Okay. So let us take one example on functional dependence. Examine for functional dependence. Examine for functional dependent, and if dependent, find relation between them. Examine for functional dependent, and if dependent, find the relation between them. Now here function is given, u is equal to x square plus y square plus 2 times xy plus 2 times x 2 times y, v is equal to e raised to x into e raised to y. Now, so what is the method to show that u and v are functional dependents? So we first find Jacobian of uv with respect to xy. So by definition of Jacobian, of uv with respect to xy is equal to determine u with respect to x, u with respect to y, v with respect to x, and partial derivative of v with respect to y. So partial derivative of u with respect to x is 2x. What is partial derivative of u with respect to x? Plus 2y plus 2. Partial derivative of u with respect to y is 2y plus 2x plus 2. Partial derivative of v with respect to x is e raised to x into e raised to y, and v with respect to y is e raised to x, e raised to y, because derivative of exponential function remains unchanged. Now simplify this, find the value of this Jacobian. So from first row we can take common 2x plus 2y plus 2, and from the second row we can take e raised to x into e raised to y common, and so here is 1 1 1, and hence it is equal to 0. Therefore Jacobian of uv with respect to xy is equal to 0. Hence we say that u and v are functionally dependent. If Jacobian is 0, then we clearly say that u and v are functionally dependent. That means u and v are depend on each other. Now what is relation between them? Now here find the relation between u and v by eliminating x and y. So you have to eliminate x and y and find relation. So here u is given, it is x square plus y square plus 2 times xy plus 2x plus 2y. Now I can write this as x square plus y square plus 2 times xy is written as x plus y bracket square, and this 2 times this written as 2 times xy, this and this. Now, but what is the value of x plus y? We know that v equal to e raised to x, e raised to y. So v is equal to actually what? E to the power x plus y. So x plus y is equal to what? X plus y is equal to log of v. So it is a log of v bracket square plus 2 times log of v, and this is a relation between u and v. So in this way we can calculate relation between u and v. So let us take another example. Examine for functional dependence and if dependent, find relation between them for the following function. Two times y square. Three functions, three variables. So examine for functional dependent and if dependent, find relation between them. Now here we have to show that Jacobian of UVW with respect to XYZ equal to 0. So we first find Jacobian of UVW with respect to XYZ. So by definition of Jacobian, so Jacobian of UVW with respect to XYZ, ये कितना होगा? What is formula is partial derivative of u with respect to x, u with respect to y, u with respect to z, v with respect to x, v with respect to y, v with respect to z, w with respect to x, w with respect to y, and w with respect to z. Calculate this Jacobian. What is ux? Ux means partial derivative of u with respect to x. Therefore, the value of this Jacobian is equal to partial derivative of u with respect to x is 0, u with respect to y is 1, and u with respect to z is 1. V with respect to x is 1, v with respect to y is 0, v with respect to z is 4z. W with respect to x is 1, w with respect to y is 4z minus 4y, and w with respect to z is minus 4y. Now solve this determinant. Solving this determinant, we get 0. And 0 into this, what? This term becomes 0. Minus 1 into, it is minus 4y into product of this. Minus 4y into minus 4z plus 1 into product of this minus 4z minus 4y, and if I simplify this we get 0 answer. Definitely it is a Jacobian of UVW with respect to XYZ equal to 0. So therefore UVW, we can say that, are functionally dependent. Therefore UVW are functionally dependent. Now what about relation? How to calculate relation between UVW? So we can find the relation between UVW by eliminating x, y and z. To find relation between UVW, between u, v and w by eliminating x, y, z from the relation. Okay. X, comma, y and z. So w equal to x minus 4y minus 2y square. Then I have to eliminate this I have to adjust u and v and eliminate this x, y, z. X minus 4y z minus 2y square. Add plus minus 2z square. Add and subtract plus minus 2z square in order to adjust the term. So value of this is equal to x minus 4yz minus 2y square. What is the value of this? So x plus x plus 2z square. So I am writing here x plus 2z square minus 4yz minus 2y square minus 2z square. So x plus 2z square is v minus 2 times y square plus 2yz plus z square, and that is v minus 2 times y plus z bracket square. And what is y plus z? Y plus z is what? U. So w equal to v minus 2 times u square. W equal to v minus 2 times u square is a relation between u, v and w. Okay, one more example I am giving. Examine for functionally dependent and if dependent, find relation between them, and the function is u equal to sin x plus sin y and v is equal to sin of x plus y. U equal to sin x plus sin y and v is equal to sin of x plus y. So we first evaluate Jacobian of uv with respect to xy. So by definition of Jacobian, so Jacobian of uv with respect to xy is equal to, then this is partial derivative of u with respect to x, u with respect to y, v with respect to x, v with respect to y. Let's simplify this. What is partial derivative of u with respect to x? What is u? Sin x plus sin y. So differentiation of sin x is cos x. Differentiation of u with respect to y is cos y. Differentiation of v with respect to y is cos x plus y, and differentiation of v with respect to y is cos of x plus y. So solving the determinant, solve the determinant. So cos x plus y minus cos y cos of x plus y. Now this actually what? Which is not equal to 0. So Jacobian is not equal to 0, and hence we say that u and v are functionally independent. U and v are functionally independent, that is there is no relation between u and v. No relation between u and v. Thank you very much.